here, and welcome to another one of our foundational webinars. Today we're going to be talking a little bit about alignment and intersections. Hopefully this will be useful for some of you. We're going to be doing polls and having fun and take you down to the top of the next hour. My name is David Orr. I'm the director here with New York State LTAP Center, part of the Cornell Local Roads program here in Ithaca. And actually that picture behind me is not tropical. It's actually Cayuga Lake on a beautiful sunset that I picked up one day. So let's start talking a little bit about some things. I do want to remind you, if you haven't been on one of these webinars before, or it's been a while, if you go to the bottom of your screen, you can check your audio settings. We do advise you to open up your chat pod. It's not two-way, it's a one-way communication from us, but if you open that up, we have a handout that you might want to go through. It's got some really good resources and an outline of what we're talking about today. And that way we can get messages to you. We may ask you to raise your hands now and then, so know where that feature is. And finally, the way you can interact with us is use the Q&A feature. Any question you've got, put it in. If it's a technical one, Jody or Amanda sitting in the background will help you with that. If it's a question dealing with the webinar, that's my job. So with that, we're going to go ahead and get into this. If you're wondering, this is worth one professional development hour for continuing education in engineering here in New York State. Only the person who's registered gets to get that credit. So just keep that in mind. And it is counted as a course, which can be useful since half of your PDHs have to be courses. If you're from another LTAP center or another state, you're going to have to check with them and they'll let you know whether it's worth a PDH in your particular state. Now, this is the second of our summer webinar series, which started last week with flagging. Will end actually after the summer, if you count the weather people, on September 10th with snow and ice. All of these will be recorded, and the ones with stars beside them will be definitely worth professional development hours. We're looking at a couple of the others, but assume for the moment, these are the ones with PDHs for those who need. Okay. Now, we do also have a couple of other engineering workshops that are going on this summer. Please sign up for them. We want to make sure they're filled up. One is on the Americans with Disabilities Act, making your rights of way accessible for everyone. And that's going to be July 9, 10, and 11, Dutchess, Onondaga, and Genesee counties. And then one on project management, 6th, 7th, and 8th in Ontario, Broome, and Albany County. And those will all be worth 6 or 7 professional development hours. One of the fraction, but you can look it up on our website, which I'll show you at the end of our hour together. And of course, our fall workshop series is out, and we have a whole bunch of classes, and we're looking at next year's schedule as well. Okay, so that's our quick and dirty introduction. Get that out of the way. Let's do a little bit of a welcome. See who's on the class today. And we're again using polls. It's pollev.com/DavidOrPE. If you open up your chat pod, it actually should be in there. You can click on it, or you can type it in, or even download the app. If you can't access it, please put your answer into the Q&A pod so I can at least get a sense of who's involved today. So who do you work for? You work for a town, a county, a city or village, state or federal, tribal, consultants, contractors, or the weekend. And we'll see how many honest folks here are working for the weekend. Okay. And we have someone who's put in, they work with the county. Okay, so we have a county person on top. Cool. Okay, so about half of you work for counties, quite a few are cities and villages. We have some consultants and a few honest folks with the weekend and a couple of towns. Okay, cool. What's your job? Are you an administrator? Are you the highway superintendent or DPW commissioner? Are you an engineer by your primary role? Are you out in the field? Are you supervising those people? Are you an elected board member? Or none of the above? If you put in none of the above, please put in the Q&A what that is. You know, I see there's an engineer added to this, and I guessed most people would be engineers today. So hopefully I can pick you up one item that you're going to learn today that would be useful, and we'll go from there. Okay, cool. Good to see. And then, of course, where you're from. You can click on the map and tell me where you're from. And just click your map there. We got Buffalo, Rochester, Bath. Okay. And New York. Okay. I'm assuming New York City in that case. Okay. Rockland County. So A lot of the materials we're going to be talking about today come from our full day class on solutions for safer roads and streets. This is a class that we hold every other year. It's on the schedule for next year, so look for that. It's a full day class. It covers everything from intersections like we're talking about today to many other items. And we do have some other safety training that's going to be coming out later this summer dealing with local road safety plans and signs on corners. But today we're going to talk about intersections. But all of this deals with something called safe systems. This is the new approach from FHWA, and the concept is to stop siloing things. We used to do the 3 E's or 4 E's that you've probably known about, where we would talk about engineering and enforcement and education and maybe emergency response, but we would silo these things rather than trying to be a little bit more holistic and bring these things together. And so the idea is to look at the user, look at the vehicle, look at the speeds, which might include enforcement, might include other things, the road itself, and post-crash care. All of these things together improve safety. And the idea is to have redundancy so that one mistake doesn't lead to a fatal crash or a serious crash. It's life-changing. So that's really the goal that we've got here. We're going to use that over the course of the time together today to try to improve safety for everybody, okay? And today, of course, we're talking about primarily with intersections. So to start, our first poll, it's not just who you are. What is the goal of a good intersection? What would you put down as the goal of a good intersection? Let's see if you come up with the list that I've got and also that's out in the literature these days. Okay, we have efficiency. Okay, that's good. Good sight distance, safe passage of traffic. Yeah, safety is the first thing y'all put down. Several of you have said safety. I've got a safety over in the Q&A. Safe movement of pedestrians and vehicles. Ooh, I like that one. It's the idea that it's not just the vehicles. We really need to be looking at all of the users of a particular intersection. And the concept of level of service, or LOS, as you put in, is part of that. What is the level of service? How much backup do we have? We don't want to delay people too much, and yet at the same time, we have to realize there's safety issues, who's got rights to go left, right, and so on. And I like that one over in the Q&A, someone put good maintainability. And that's actually a pretty important one. When you're designing an intersection, can you make it such that you can maintain it? You know, if you got a really nice looking, cool road or intersection or anything, but it's difficult to maintain or it's expensive to maintain, that could be a challenge for you long term, especially as budget cycles go up and down, because you and I both know maintenance is one of the first things that gets cut. So essentially, you got most of it. You got safety, good. Smooth flow is a pretty important one, which leads to also helping with both safety and capacity. Capacity and efficiency are part of it for all users. And you need to account for all of the users. Okay, so let's ask, who uses an intersection? Let's see who you come up with. Who uses intersections? Let's see what you guys come up with. Vehicles, the public. Yeah. What kind of vehicles? Pedestrians. We got multimodal issues, which means lots of different kind of vehicles. Let's see what other ones you guys have. Okay, bicycles, trucks, cars, okay, motorcycles, emergency responders, deer. Yeah, they have a hard time with those push buttons, but yeah, okay, deer. Supersized trucks, semi-tractors, yeah, people with disabilities of different types, everything from people in wheelchairs to walkers, that people are colorblind could make a big difference. Okay. Trains. Yeah, a train is an intersection where it crosses a roadway. We put that same brain on that says intersection when you have a train crossing, and you might be thinking about that. Mopeds. It's interesting. I don't see a bus today. Last time we did this, people put down buses. So again, think about all of the vehicles that are using your particular roadway. And before you even start thinking about what you're going to do, you really want to go out and you want to evaluate what you've got. Now, this is a really easy way to do it. This can be done with lots of detail, with less detail, really comes up to what you want to do with it. But imagine just taking a stretch of roadway and essentially drawing a diagram. Obviously, these days, you could start by taking a picture from Google and using that as your starting point, but list all the safety features, list all the concerns you've got, And of course, in this particular case, there is an intersection, and we'll see if my friendly pen is going to play well today. And we got an intersection up here, which has its details as well, but there's an interaction, of course, that's going on. So we see that we've got some trees, we've got a Y intersection, we got lots of signs. So the question is, what can we do to improve the safety at that particular intersection? So the first thing you always want to do is you want to start with essentially an inventory, okay? That sounds like the beginning of asset management. Well, actually it is. There's the same techniques we use for asset management we can use for intersections in anything we're dealing with roadways and safety or intersections. And that includes inventory, figuring out what's wrong, what are the possible repairs, and of course, how you're going to pay for it. Now, in terms of intersections, what is the percentage of crashes at intersections? And now when I'm talking about percent of crashes, I'm talking about the serious and fatals. The serious and fatals, what's the percentage of crashes at intersections? Serious and fatals. Okay, got a range here, people all over the map. If we were looking at all crashes, the answer would be about 40%. C would be the correct answer. But if we're looking at the fatals and the serious injuries, it's about 50%. It's actually more than 50%. So anybody who said D or E, you're probably closer to the mark. A lot of crashes occur in intersections. And the reason, of course, is the types of crashes that we get at intersections. So let's ask that question. What type of crashes do we get at intersections? What are the kinds of crashes that we deal with? Get a T-bone, one of the most dangerous. Yeah, right angle crashes, some of the most dangerous. Yeah. Rear end crashes, especially when we stop people, those can be very serious. Okay. Yep. Some of the most dangerous crashes we get are some of the ones that occur at intersections. Yeah. We can get ones with vehicles and pedestrians, and we'll talk in a minute why that's really usually a really bad mix. Okay. Heavy metal, vulnerable user, not going to work too well. Okay. We can get some side swipes. We can get some crossing kinds of things. There's lots of different kinds of crashes, but to think about the kind of crashes you're going to deal with. And if you look at a standard intersection, think of the conflict points. In this particular case, the standard four-way intersection, we have diverging. Diverging could include things like rear ends actually fall into that category where vehicles going to turn, and as it's getting ready to turn, another vehicle hits it. It could be a merging where someone turns into somebody else, or it could be a crossing. And the crossings are by far the most dangerous because it's those T-bone crashes that occur. Look at the number of them that we see in a typical intersection, okay? There are 32 vehicle conflict points, and about half of them, a little more than half of them, are crossing ones, which are very, very serious. So that's when we put in traffic control and other tools and things to eliminate these problems. That's just vehicles. But of course, if you've got an intersection with pedestrians, you're going to deal with that reality. And truth be told, most people don't know this. But let me ask you a question. I'm standing at this intersection. Let's assume there's no traffic light. No traffic light. Okay? No traffic light at all. Just a stop sign. Who is the right of way if I want to walk across that roadway? Raise your hand if you think it's the car. Well, that's good. Raise your hand if you think it's pedestrian. Ah, a lot more of you are raising your hand. That's good. The pedestrian actually has the right of way, unless there is signage that tells them otherwise, or a traffic control device. Okay? So we need to put crossings, because most people, I'll be honest with you, the public doesn't really know this. So we like crosswalks. They really help. They keep things a lot safer. But of course, as soon as you put in crosswalks or there are pedestrians, we add a lot more conflict points, okay? And those conflict points could also be, we know, with bicycles and other things, but pedestrians is one of the best places to start. So let's imagine now we're in a situation where there's a pedestrian who's crossing and somebody runs a red light. And it could be a bad day. Luckily, this case, it's a broken arm, only a broken arm. Don't ask me how. Okay? It was only a broken arm. Now, that pedestrian was walking against the walk signal. But again, we don't want one mistake to lead to a serious or fatal crash. We were very fortunate in this particular case that nobody seriously got injured beyond a broken arm. I know that the person is serious for them with a broken arm, but the reality is they walked away really lucky. Okay. Now, why was we worried about intersection speed? Well, that comes down to the concept of survivability. If a person gets hit at 23 miles an hour, studies were done in Europe, so they were actually metric numbers. It's just why they're not quite even. Okay, we'll say 25. There's a 10% chance that they're going to be killed. Okay, of course, if they're older or younger, those numbers would actually go up. Injuries is going to be about 22%, or about a quarter of the people will get serious injury, a life-changing injury. So that means we're talking about a third of the people we're going to have a problem if they get struck. So we want to avoid that at all costs. But as speeds go up, it gets even worse. At 42 miles an hour, half the people are killed. A third of the people have very serious injuries. So we're only talking little over 10% who are able to just walk away with that broken arm. And of course, if they're going at the state speed limit of 55 or a little bit faster, 58 miles an hour, it's a 90% chance that they're going to be killed. And about a 99% chance it's going to either be a fatality or a serious injury. So we want to try to avoid pedestrians at high speed. And that's a hard thing to do in some cases, but we'll talk about that a little bit as we go through our hour together. A lot of the things we can do to help are to improve geometries. And we can get some really odd geometries, especially in our older communities in New York City and Albany and Ithaca, all kinds of places as I travel around New York State where it's older alignments can be very hard to fix. But let's realize there are geometric standards out there. Obviously, there's the AASHTO Green Book, which comes from the old AASHTO yellow and blue books, and now they're green. There's the New York State Highway Design Manual, which just essentially uses the AASHTO Green Book as a starting point with some minor modifications. It makes sense in the climate and conditions of New York. AASHTO does have a very low volume, just low volume road standard that was updated about 5-6 years ago. You could develop your own geometric standards, but the reality is that you really want to use somebody else's for a variety of reasons, not the least of which is there's good liability protection if using somebody else's standards. So let's look at the most common intersections that are out there. Obviously, you could have a T intersection or a four-way, numbers 1 and 5. They're actually pretty similar with some modifications. You can get high angle intersections like 2 and 6. You get the lovely Y that creates its own issues because now you got a lot of conflict points that you're going to have to deal with. But if you think about it, you're going to have essentially, when you do that with a Y intersection that we've seen like that all the time, you've really got 3 T intersections. Okay. And they're usually a high skew, which we'll talk about why that's problematic as well, or 3 Ys if you prefer. Okay. You can get these weird kind of intersections like this. There's one I'm going to be walking through after lunch today because I got to go vote. And to get to where I need to vote, I'm going to be going through an intersection that's got 5 legs. And the challenge of that can be lots of fun. And of course, we'll talk a little bit about the modern roundabout, the good, the bad, and some people's dislike of the modern roundabout. So let's look at the 4-leg, okay? Now, the 4-leg we've already noted has a lot of conflict points. 32 conflict points with vehicles, assuming they're 2-way roads. Got another 24 to pedestrians. And of course, we'd like to keep the distances that pedestrians have to walk as short as possible. So what we do is we may come in here and go put a crosswalk in, right? We'll put some crosswalks in here. And by keeping these radius nice and tight, it's going to really help the pedestrian, but it shortens the distance because if you had a wide radius, it's going to be a longer distance for them to have to travel if the radius were way out here. Good for the truck, not so good for the pedestrian because they got a further distance to go. And of course, we know about turning templates and things like that with a truck, because when that truck wants to make that turn, he's really only got a couple of choices to get from point A to point B. Okay. He can cut the corner and stay in his lane, but he might track right across the curb line. And so we think, well, we're going to widen that curve out. and we'll do that. But of course, that's got its own issues. The other possibility that he's got available to him that's not always a fun one is, and let me get rid of the truck out of the way here, is he can come in here and he can go up with his truck. And he swings out like this. And he winds up usually going into the other lane, even further than I drew it. It might be way over here. In fact, that intersection I'm going to walk through today has a tight corner because the angle's not 90, and the buses actually have to go into the other lane. And when people don't stop at the stop bar that they're supposed to stop at, which is way back from the intersection, it creates a conflict point. So think about all the vehicles using that particular roadway and what can you do to try to make that road, that intersection efficient. So the corner radius makes a big difference. It's a really tight. Now, there's other issues here we're going to talk about in terms of sight distance. But let me ask you, what would you do if you've got a tight corner radius? What are some solutions? Give me some solutions for a tight corner radius. You could do stop control, and that can work. But again, think about the turning radiuses for the trucks and where you put your stop bars. People don't always stop. You can widen the intersections, which helps the vehicles, large vehicles, but makes it harder for the pedestrians. You could put a flexible delineator. You can put in mountable curbs. Yep. Okay. What else you come up with? I'll give you a couple more secs. Throw in a couple more. You could put in a signal. Okay. I'm looking for two more items that might be possible. Remember, it always comes back to money. You could ban truck traffic. That actually is not completely unheard of. Put in a truck route, make sure a good place for the trucks, and hopefully the only large vehicles that are going there are delivery vehicles, which are really a little tighter, a little smaller. And once in a while, you got to have a really large vehicle. It's pretty rare occasion, and it can handle it by other means with mountable curb or something like that. And yes, you could even think about a roundabout. The other one that you do see a lot, and you may not be thinking about it, is you could increase the effective radius. You put in a widening lane, you could put in a turning lane. Okay. This is actually here on the Cornell campus. They were paving the road. So the picture is from when I was paving, or when they were paving. So I got the picture, but you can see they put in a turning lane because it's a really sharp corner. And we're talking about a 75 degree angle. Would be really almost impossible for that vehicle to go all the way down to where the guy is on the far left and swing all the way around. So they put it in a turning lane. But then they had to account for the fact that there's a lot of pedestrians there. So they had to account for that fact. And I, to be honest with you, do worry about the sight distance. These vehicles are coming around the corner because you can see the edge of that building there. But it's something to think about. There are options, but then if you put that in, how do you deal with the fact if there are pedestrians, if there are bicycles, what other vehicles are going to be using that particular site? And then what kind of traffic control do you use? And of course, does anybody notice the thing that's missing on that turning lane? See if anybody can catch in the Q&A that's missing on the turning lane. Pavement striping? There was some pavement striping. Ah, very good. You got it. Very good. There should be a yield sign over here on the right. Okay. They only had the one on the left for a while. So they got fixed. When you come to an intersection, one of the things we got to think about is the sight distance as you're getting up to the intersection. Okay. Can you see it before you get to the intersection? That's one sight distance. But the other one is when you're at the intersection itself, can you see? So there's several different sight distances. Remember, when we're talking sight distance, we normally start with stopping sight distance, which includes the perception reaction distance, how long before you put your foot on the pedal, and the actual stopping distance to stop the vehicle before it hits the object. Hopefully it's most of a rock, but obviously you don't want to hit another car or even worse, a pedestrian. Okay. So these are sight distances that we can talk about. And by the way, in the current version of the Astro Green Book, they've added in something called the decision sight distance, which adds a little bit more time to that perception reaction time to deal with the fact that when you're in an urban area, especially, there's a bit of distraction. So we're going to increase the time before you actually put your foot on the brake. But even that can't account for if people are on their cell phones, if they're not really paying attention. But it can be helpful. But that same decision sight distance also is the basis of, is there sight distance at a corner? Is there enough distance for you to get out and get your vehicle up to speed and see around the corner? The same concept can be used. So let's look at a tight intersection, okay? Now, obviously in this case, I think we probably need to do more than a yield sign in this particular case, because you can't see around the corner. Now in the Astro Green Book, there's a chart and you can run the math if you'd like to, but the concept is that a vehicle is sitting at the stop sign or yield sign or whatever traffic control point there is. And they're either going to turn to the right or they're going to turn to the left. Okay, so I'm going to lower everybody's hands. Okay, everybody's hands are down. I want you to tell me which is more critical, the right turn distance or the left turn distance. Raise your hand if you think it's the right turn. Raise your hand if you think it's the right turn. Okay, we've got one person brave enough to say right turn. Okay. Let's now look at how many of you, I'll lower the hands, how many of you think it's the left turn? Most of you think it's the left turn, okay? And the reason that the left turn is usually the more critical one, but I'll come back to why it's not always the more critical one, is because you have to first cross the lane on the left and then accelerate in front of the vehicle to the right. The advantage, however, of this particular case is if you can see to the left and see well to the right, you actually have the advantage of already having picked up some speed when you enter the lane. So it is a slightly larger distance. And there are some times, however, that it actually is worse to the left because you got to accelerate in front of a vehicle, okay? That you may not be able to see because you can actually see sometimes further with that far vehicle because the angles aren't quite as steep. So just make sure you check both of them, okay? But the more critical one is usually the left or cross distance. Can you get in front of that vehicle? And so you can do the math, okay? So I did the math, pulled it from the Green Book. So a sight distance on a left turn or cross major road in feet varies by the type of vehicle, okay? So for a passenger car, you need to see about 325 feet at 30 miles an hour. About 560 feet at 50 miles an hour and over 600 feet, 2 football fields at 60 miles an hour. But look what happens when you get a truck. A delivery truck is going to be another 200 feet at 60 miles an hour. By the time you get to a tractor trailer, they need to be able to see 1,000 feet. So you're going to have to think about traffic control if you got a lot of trucks, if you don't have a lot of sight distance. Now, let's look at this in a different way. Let's look at the distance the vehicle coming down the road will travel. Okay, so not the vehicle coming out, the vehicle coming to the intersection. So now let's look at this from a time standpoint. How much time does it take before they get to the intersection? So if we look at that, time is the sight distance that they need divided by the speed times a conversion factor, 1.47 or 1.5, if you really want to do the math. So now let's look at the sight distance in seconds. So the sight distance in seconds for passenger cars, it's about a little over 7 seconds, 7.4 to 7.5 seconds. And turns out the reason, by the way, that it's not a going up or going down like you'd expect has to do with the fact that that perception, reaction, and braking distance don't work out the way you'd think. And if you want, we can talk about the math. For an SU truck, a delivery truck, it turns out to be about 10 seconds. For a tractor trailer, it turns out to be about 11 to 12 seconds. So if you look at it from that standpoint, rounding up to be a little conservative, if you're standing at that intersection, you're standing at about the place where you want to be able to stop a vehicle and decide what you need for traffic control and are there good sight lines, count. If it's a car, they need about 8 seconds in both directions, primarily from the left and right, but 8 seconds. For a truck, they need about 10 seconds, delivery truck, dump truck. Semi-tractor, they need 12 seconds of time. And that's a good rule of thumb to decide whether or not you've got a sight distance problem and that might help you with your traffic control. Okay, so let's look at the traffic control. You could have no control. You could have a yield sign. You could put up a stop sign. You could put up a traffic signal. And of course, we could also talk a little bit about other intersections like roundabouts and stuff like that. But let's look primarily at the standard intersection. We're going to assume no control up the traffic signal. So when would no control be a good option? When would you put up no control on an intersection? And you think there's no controls in New York? There's actually quite a few. You have really large sight distances, significantly lower traffic volumes, preferably under 400 vehicles a day would be preferred. Low traffic, good sight distances, relatively low speeds, but not always. If it's extremely low traffic and there's tons of sight distance, you're going to put up a sign that people are going to ignore anyway. Okay? So think about that. Ramps, yeah. So actually, technically, if you look at the ramps, there's actually a yield sign at most ramps for the interstate. Okay? But yeah, there are sometimes we don't put up any signs at all. Okay? Someone put in rural. Some of the places I know of in New York State that have no traffic control at all are residential areas instead of urban areas where there's plenty of sight distance, low traffic volume. Putting up a stop or yield sign is just going to be ignored anyway, so they don't put up a sign at all. But normally, yes, it's low volume, good sight lines. Think about it. Most driveways technically have no traffic control. I mean, sometimes the law says you're supposed to yield and stop, but there's no sign placed for anybody because the law still says you're supposed to yield the traffic if you're coming up on an intersection, whether there's a sign or not. Okay? So let me ask, when is yield control a good option? When do I have to put in that yield sign? What forces me to go from no control to yield control? What am I going to be doing here? It could be low volume, maybe not. What else might be a good option? Relatively low speeds. It might be low speeds because of the way I've laid out the alignment. That's what we do with roundabouts. We actually bring people in and set their alignment so we can keep the speed down. Might be want to start with yield signs if you got higher speed. You got to have good sight distance. That's probably the biggest key. You really want to be able to see. And the concept of a yield sign is that you can still stop. You can see the yield sign. And before you have to decide whether you need to stop or not, your sight triangle is not such that you can see any vehicles. If you've got plenty of sight triangle, you could get away with just a yield sign. So that sight triangle means is as I'm approaching the intersection, I can see that 8 to 10 to 15 seconds. I need a few extra seconds to get to the yield sign to decide, can I get in front of that vehicle or not? So really, we're going to be dealing with really good sight distances, maybe merging things like that. Okay? So the sight lines are good. There's low delay, but remember, you can still stop as you're approaching the intersection. And so a lot of the guides that are out there talk about that very issue, deciding whether you're going to put up a stop sign or a yield sign deals with that sight triangle distance. In this particular case, it's a yield sign, and to the right, you can see plenty of distance before you get to the intersection to decide, there's a truck coming, I got to stop. There's a car coming, I got to stop. But remember, look in both directions. Look in both directions. So when do I have to go to stop control? When is the stop control a good option? When am I going to be going and putting up a stop control sign? Higher volumes, okay. Traffic signal can be too expensive, especially for the cost, yeah. Maybe a high number of accidents, okay. Or sight distance. Sight distance is usually the driver, and remember, what a stop sign is doing is not speed control. Please don't let people use stop signs as speed control. A stop sign is there to essentially decide who has the right of way, who goes first, who goes second. If it's a two-way stop intersection, you're essentially assuming the main road has the right of way and the vehicles coming in have to yield that right of way, but you have to have them stop because there's too much traffic or there's not a sight distance. There are warrants for all of this if you really care about in the MUTCD, but I want you to think more about holistically what makes a good stop sign, okay? And you may need a stop sign if you've got a lot of pedestrian traffic or you've got a lot of bicycles, again, to assign the right of way, assign the control, okay? Now, we do need good installation for stop signs. This one might be a little bit low. Now, luckily it's in a parking lot, so you can get away with it, or next to a parking lot, but we probably could do a little bit better than this in terms of height. That's a different webinar later, coming up. Here's the reason why I really worry when I see people want to using stop signs as speed control. This is out of Michigan. And what they did is they had done a study beforehand. You can see the blue line, their traffic speeds never quite got to 0 on average. This is the average speed. So you can see there was a stop sign at Edwards, there was a stop sign at Millard Street, and there was proposed to put another stop sign at Price Street. And what happened when they put the stop sign at Price Street is, sure, the speed went from 30 miles an hour going through the intersection down to about 8 or 9. People didn't stop. They were frustrated, and look at the speeds between. They actually, in some cases, went up, and in some cases, they went down. But the point is, if you're trying to use it for speed control, it's probably not going to do quite what you think it's going to do. And this is one of the more important points. Keep this one in mind. One of the most dangerous places when it comes to intersections is people are coming in and out and are accelerating, okay? So if you think about it, if we look at acceleration being the slope of these lines, that's why they have these zones here they've marked off. These places that are inside of this zone here, we've got a lot of acceleration going on, big changes. Those are the most dangerous spots. We've actually made more dangerous locations with higher accelerations, okay? So it doesn't always do good speed to have speed control with stop signs. Not a good idea. So when do I have to put up signals? So I got my last choice. You know, they're not cheap. You know, we're talking, could be over a couple of $100,000 depending on the intersection and which you're going to have for mast arms or span wire. But when do I need to have signals? Possibly with high traffic volumes, high number of crashes. It's really hard to decide who's got the right of way. If signs themselves just aren't going to work, like the person put, that's great. A lot of times multi-lane, you almost have to start thinking about that because it's really hard to do that with just stop signs. A very busy intersection, okay? So again, usually that's driven by traffic volume, more urban areas, okay? And of course, again, someone mentioned the idea of the warrants. You could look at the warrants, and of course, it could help you improve the level of service. And this is important. It can be very important if you put it with pedestrian signals to help with vehicles and pedestrians interacting more safely, okay? To give their assignment of a right-of-way for the pedestrians at certain times. So it's giving you some options, yeah. The thing about it is, think about when you're putting the signs up. Are they expected? Are they anticipated? In this particular case, it's an older intersection where they didn't have the signals over the roadway. It's really hard to see that signal head off to the left and off to the right. There is one there in the distance, but it's really, really hard to see. And I'll point it out here. Get my pen. And then there's the signal head. Let's get a color you guys can see. There's the signal head right there. And there's the other signal head right here. It gets lost with all the other cars. So that's why we really want to put those signals over the top. That's why that's now the standard. It's a lot better in that respect, okay? Now, I will tell you right now, we know they cost more. Really want to get somebody in to design these things and set the timings properly. Preferably these days, actually, you want them timed if you're on a corridor, so they're all tied together. We don't have time to get into that too much today, but it's something to keep in mind. Okay, so now let's go back and look at our intersections. I want to focus on 3 in particular, though in reality, I'm really focusing on 6 and 7 as well, but I want to focus on the ones where there's lots of sharp angles, okay? You could even argue y as part of this equation as well, okay? You could even argue that, so. high intersections. So let's go look at 2. It could be 6. It could be any of them. Okay. I pull up to that intersection. Okay. In this particular case, there's a curve coming in. And for me to be able to see a vehicle because of the angle, you have to be able to look behind you, right over your shoulder in this little window. Your mirror isn't going to be able to see much. Your rear view mirror can't see much. You really got to turn your head. That's a really risky intersection because it's really hard for you to see and judge the distances in that particular case. Okay. So we really don't want these high intersections. We really want to have a perpendicular intersection. So we really would like to bring this roadway in like so. Okay, we'll draw first this, then we'll put our radius in, and then we'll erase away. Oh, it's got to erase the whole thing. There we go. There we go. And I probably got that off a little bit. But we really want a wider intersection. Okay. Now, the temptation is well, if I do that, I'm going to purchase a lot of right-of-way. Because if you think about it, if I do that, I'm going to buy all this land over here, right? So the temptation that we have is, well, I can get away with less, right? So I'm going to come in here instead of doing that. I'm just going to take the minimum radius. I'm going to just do this. There's my center line. And now my new road is just a little wider. Get away with as little as I can get away with. Okay, sounds good, right? The problem is if it's not long enough, if that radius is too tight, we get a situation like this, where vehicles look at them as they're coming in and out of that intersection. They're not turns to that 90-degree point. They're actually wanting to go down the roadway. In this case, they've got a skewed intersection. And think about a truck trying to come down this. That's the vehicle that needs to be as close to perpendicular as you can. So the tangent coming off of that intersection needs to be long enough for the larger vehicles that you expect. If you expect just a few tractor trailers, maybe you get away with less, but you need at least long enough room for any delivery vehicles. And if you do have a lot of tractor trailers, you're going to want that full distance of that tractor trailer or that farm equipment or whatever to be already on the full tangent. So in this case, if that's my truck, this defines my road right of way. Got the other lane, got the right of way. Okay, and I didn't draw my radii very well, but you get the idea. And yes, it is more right of way, but think about the users. And if, by doing that, by the way, you also may need to think about the pedestrians. You may have to pull back a little bit because there's a pedestrian crossing as well. Not always easy, but something to think about. Okay. Now let's look at that Y intersection. Remember, I said earlier that Y intersection, the challenge there is that we have really 3 intersections. Okay. So in this particular case, you've got 3 intersections you're dealing with. So you have to actually have a stop sign. Let me get a red color here. You got to have a stop sign here. You have to have a stop sign here. And you have to decide, are you going to have a yield or a stop sign there? A lot of them have nothing, but really it's a no control intersection then. Is that the right thing to do? Or do you actually need to have a stop or yield sign on one of these legs to make it safe for everybody? And so you've increased the number of points. What we would prefer, not always easy to do, is to come in at 90 degrees. Okay, not always easy to do, and there's not always the only choice. But again, something to think about, because one of the worst things we can have is somebody comes swinging off one of those Y intersections at high speed because I can get in front of that vehicle. They hit them, and we have a really bad day. Okay, which is one of the reasons we like the roundabout. Okay, the modern roundabout does a good job of merging things in. Okay. And it reduces the number of conflict points. As you can see, we've dropped it now to 8 vehicle conflict points. None of them are crossings, the more serious T-bones. And only 8 pedestrians once, one at a time. But I can tell you right now, if you're going to include pedestrians, if they're part of your roundabout, it's not a rural roundabout, you're not worried about pedestrians, has to be included in the design. Let's go back and look at our picture. In this one, they thought about the pedestrians, even though if you look carefully, there's no sidewalks. This was a, what are we going to do in the future if there's pedestrians there? There's no sidewalks right now. So they were thinking about pedestrians when they built this thing. You need to be thinking about that as well. And remember, the thing about a roundabout is vehicles don't have to stop. They tend to be moving quite a bit. So the vehicles are always coming around. Okay? We'll see if the video plays. It was fighting me this morning. You gonna play today? You're not gonna play today either. I upgraded to Windows 11. There are days when I wonder. The idea is roundabouts work because they keep people moving. But think about if you have pedestrians, do you have to do something different? And think about the radius for the trucks that are using this, what kind of gaps are available. There are certain times a day it could be a bit of a challenge for you. So keep those things in mind, okay? Now you may come across this in some urban areas, these little mini roundabouts in intersections. Actually, I think they're actually pretty cool. They have their place. Again, almost the same concepts that you would be using for the different types of control. These are only going to work if you don't have semi-tractor trailers, relatively low volumes, low speeds. It could be a residential commercial area. It might even be a mixed use area, as in this was in the city of Ithaca. This is actually almost a mixed use. The building on the right is commercial, the building on the left is an apartment, and where I'm standing are a whole bunch of apartments. But again, think about the options for intersections. There's quite a few things that you can do. So what I want to do is I want to spend our last 10 minutes or so together going through a few case studies and talking about some of the things we've talked about in our time together. I want you to think about what you would do, okay? So now there's an intersection that's really close to my house, okay? At this particular intersection, this is a Google Earth view I got of it off the web. And I'm going to draw a little stick figure where I'm standing. Make sure I get the right stick figure. Oh, gotta turn the pen on. The stick figure, I'm standing here, okay? When I took this picture right here. So this is right here. That's where I'm standing. And you can see I'm standing down the road a little bit for the second picture. So the primary traffic is cars going down this main road. This is Cornell Street. Okay, that's the primary traffic. Okay. And there's a lot, and I'll draw it in a different color just so we can see it. There's quite a few pedestrians, and there's only a sidewalk on one side. So there's quite a few pedestrians walking here. And then there is a sidewalk on this side, but there's no sidewalk beyond that. Okay. And there's no sidewalk up the other side except a little spur that only goes about 50 feet. Okay. So what would you do to make this intersection safer and not reduce capacity? And you get to put these things in the hole everywhere. See what you guys come up with. Take everything we've talked about and throw it in. Give me some ideas. Maybe you go to a yield sign versus a stop sign. Okay. Maybe you got to do a four-way. A roundabout, it's going to be expensive. Something to think about. I have no problem with brainstorming. So go for it. Complete the crosswalks. I like that idea. To me, that's one of the things I'd like to see us do more often. The public doesn't know. They don't realize what the right-of-way is. They have no idea. In fact, I'll go back up here and I'll show you what I'm talking about. While people you can keep putting your ideas in, by the way. I promise, I'll go back and look at them. If you think about it, if I put in a crosswalk here, okay, what you're going to see over here, if you're driving, is you're actually going to see a crosswalk. In fact, if you put in a pair of them, you'll see the lines. That intersection suddenly pops, okay, which is one of the reasons why a lot of times people like to actually use the ladder style crosswalk, because if the tires wear off one, the drivers can see one better than the public can. Okay, so that's actually a pretty good idea. Okay, maybe some warning signs in advance. Think about signals, but again, you have to look at the traffic volumes. I know with photographs, clear the trees for better sight distance. Again, I like trees. I think trees in a residential area are a good thing if they're not creating a sight distance problem. Depends on the traffic volumes. So again, brainstorm ideas, write them all down. There's no bad idea at all. And then figure out, okay, what can we do both economically? What's the liability? And like it or not, you got to think about what is something that's possible with the public and the politicians. That's the realistic thing. And yes, maybe putting some shoulder or center lines could help define the roadway. Remember, once you put a line down, you do have to maintain it. Okay, let's do another one. This is a little more complicated. Okay, in this particular case, we have an old state road. Let me get a good color here. I'll make the color this time. Oh, I think the blue shows up really well. So an old state road. No, the blue doesn't show up at all. Let's do navy blue. There we go. There's an old state road here. Okay, they realigned it. Okay, so now it's a town road, and there's a intersection here, and you can actually see if you look carefully, there's a stop sign here. Okay, but the vehicle's coming down the hill, and got to get my pin here. There we go. There's another stop sign there, and then there's a stop sign coming around here. The people coming around that corner. Okay, so there's a series of odd stop signs. Try to control the traffic here. Okay. There's a lot of conflict points. Okay. Traffic volumes are relatively low. What do you think you could do if you were a small town, not a lot of money in your budget, to improve this particular intersection? And what I'm going to do, I'm going to clear all the responses. So hang on. Okay, so start putting your answers in. I'm going to go back and look at the pictures. You can see what the intersection is and see what would you do here. What kind of solutions would you come up with to improve the safety in this particular case? And yeah, the traffic volumes are not such that there really is a major road. In fact, there's probably more traffic coming off the hill than coming around that old state highway. Okay, let's see what you guys come up with. Okay, some double stop signs, maybe some stop ahead signs, some median signage. Yep, make it a T intersection. Okay, that's not a bad idea. I like that idea. The challenge, of course, with making it a T intersection is if you go back to the picture, you can see there's an elevation change where you'd have to bring the vehicles down. Okay. You'd have to bring that grade down. What kind of grade can you get away with there? And then, of course, you do have the houses that are here. I'll put a better color here. The houses that are here that would be affected by that. And then you've got a house right there that would be affected if you came straight down and made the intersection do this. And you still have a Y intersection here somehow, even if you did that. I'm not saying that's a bad idea. In fact, when I was out with the town superintendent, we talked about some options, that being one of them. Again, just something to think about long-term and short-term. And in terms of what you're going to do, you might want to look at a safety plan for that beforehand. And we're actually working on that, but that's a different webinar for a different day. Okay. Got one more for you. It's hopefully a fairly simple one here. We actually got two more we're going to do. So what are you going to do here? Your pedestrians, they want to cross over. And if you're wondering where I'm standing, I am standing right here. And as you can see, there are sidewalks in this case all the way around, all over, and I want to cross here. So what are you going to do? I'll clear the responses and let you tell me what you're going to do at this intersection. Okay, let's see what y'all came up with. Crosswalk and a warning sign, crosswalk, stripe the crosswalk. Yep. So don't disagree. Great ideas. If you put in a ADA curb ramp, you're expecting people to cross there. But again, the public doesn't know this. What else do you have to do here? What's the other thing you're going to have to do to make this work? And again, I'll go back. Prohibit parking. Yeah. In fact, technically, unless it is signed to allow the parking, you can't park there. But again, the public doesn't know that. Though I know somebody who got a ticket once for doing that and didn't realizing it. And you'd have to have a matching ramp. If you look carefully, there is a matching ramp. There actually is. If you look right here under the vehicle, you can see there is a matching ramp. They really should have banned the parking. And I will tell you right now, if you've got a lot of parking along a roadway and you've got an intersection like this is an absolutely perfect place to think about putting in, and I'll get a color that works a little bit better, a bump out. Not just having an ADA, but bring the roadway out like that. So from above, it would look like, and I got to get a pen color that works better. Instead of just having an intersection like this with a crosswalk, and you're parking, oh, you don't want any parking in the intersection, so ignore that. You would actually bring this out. Maybe even to the entire intersection. Don't allow parking in it. Shorter distance for the pedestrians. And more obvious where you can and cannot park. Because if there's a curb there, really hard to park. Okay? Yep, separate crosswalks, eliminate detachable pads. Yeah. And yes, there's a car parked in front of the ramp. Okay, I'm going to just, for the sake of time, I'm going to go to one more that we've already seen. Lovely intersection. Big old Y. Okay. Actually, no, we're going to go past. We're going to go to one more. We're going to go to a rural one just because of time. Here's a rural one. There's a rural intersection. So now I'm standing here on this main road that goes north-south. Okay. I'm standing in the first picture that you can see up here. I'm standing in the second picture down here. There is a stop sign. Come on, pen. There you go. Here, the two-way stop, and here. There's quite a few crashes that are occurring. So what do you think is going on and what would you do? And I'll clear the responses and see what you guys come up with for some solutions. What do you think is going on here and what are your solutions? And I'll give you about 5-6 seconds. Start typing them in. We'll go see what you came up with. Control speed somehow. There's a speed limit on at 45 miles an hour on the main road. Maybe make it a four-way. Vehicles think it's a four-way stop, possibly. Maybe you need a stop ahead sign. Adjust the mainline profile. That intersection doesn't look like much of a skew, and it meets all the standards because there's not much of a skew. It was enough. It turns out vehicles coming up to that roadway had a hard time seeing to the left, and they had problems, and so they weren't looking enough. Human factors. So all they did was they moved the stop bar to a slightly steeper angle to make it obvious that it was a skew. It actually improved safety. They moved some other signage and things like that, but minor things. Yes, longer term, it would be best to have this be a four-way. That would be, and I'll get a color that's different than all the ones we've seen so far. Yes, it would be better long term to have this roadway come right angle. But the reality is that's expensive. So think short term, think long term, and everybody is going to be better off. Okay? Because remember, intersections can be all types. Here's an example of a crosswalk, mid-block crossing. That's an intersection. Treat that the same way as everything else we've talked today. So think about options there. Do you need signs or not? Maybe not in the middle of the village in Lake Placid, but maybe in a place where it's not obvious, you put in cross signs or one of these fancy detectors that goes like this when I push the button. Okay? So think about intersections. Okay? And with that, we're going to let you go and get out of here. Hopefully we'll see some of you next week with sources on revenue. And we'll be doing other webinars all summer. You can also sign up for other ones. And someone asked, I was waiting for this, where's the bow tie? It's above 90 degrees today, and I have no air conditioner in my office. So I follow my own advice. When it's hot, be safe. I'm wearing something that's a lot cooler. So sorry about that. No bow tie. But there was a picture of me with one earlier, if you look carefully. You remember, okay? So with that, everybody have yourself a great day. You can find recordings of this on our website. Please enjoy your day. Stay cool. Get fluids. Wear light clothing. Don't stay out in the sun too long if you don't have to. Everybody have a great day. Bye-bye.